this figure shows the common emitter configuration by using logical parts. Already I told you the IE is equal to IB plus IC. The IB current will be very small, means it is approximately 0, means the IE will occur, IE is equal to IC. See, first we can see about NPN transistor configuration. NPN, the base will be and then emitter will be is a input characteristics, then emitter and then collector part will be a output characteristics. This is the logical diagram. The emitter is directly connected to the ground and then base is connected to the VBB. It is also called as one type of input voltage, and then VCC is here, it depends upon the output characteristics voltage terminal. Here we can see the emitter will be connected to the ground and then IB is the current flow like this. Then collector is current is connected to the positive terminal of the power supply. So, it is called as reverse bias. Then base will be connected to the positive terminal of the power supply and then emitter will be connected to the negative terminal of the power supply. It is called as forward bias. So, this part is input characteristics and then that part is output characteristics. Here also we can go for the parameters for hybrid parameters. For input characteristics we can put the voltage is V, B, E and then current is IB. It is input characteristics. Then output characteristics, the voltage is called as VEC and then IC. First we have the first parameter is input impedance. Input impedance means the ratio of change in input voltage to the input current. So, HIE is equal to del of VBC and then del of IB. Here the constant is VEC. This is called as input impedance and then output admittance is called as the del of IC divided by del of VC. Here the constant is IB. So, these are the output admittance and then we can go for forward current gain, then voltage current gain. Forward current gain, current gain is defined as the del of output current del IC divided by del of input current and they kept the constant as VBC. Then reverse voltage current is defined as del of VEC divided by del of VBC. I mean emitter collector voltage divided by base collector voltage. Sorry, base emitter voltage. Here the constant is base current. So, these are the 4 important parameters about common emitter configuration. The applications of common emitter configuration is it can be used for audio frequency signal and then impedance matching signal. This slide shows the input characteristics of common emitter NPN transistor. In x-axis we can take base emitter voltage and then y-axis we can take base current for microammeter. Here 0.2, 0.4 is going like this and then this is the microammeter value. VCE is kept constant. VC is 20 voltage, we can put in voltmeter, means the graph will be like this and then we can decrease the collector emitter voltage, the graph will be like this and then we can again we can decrease the collector emitter voltage, the graph will be like this. So, this is the input characteristics about common emitter configuration. Then we can go for common emitter configuration output characteristics. Here the important three regions are occurred. One is cutoff region, then second one is saturation region, and then third one is active region. In x axis we can take the collector emitter voltage, and then y axis collector current. In a micro ammeter, the IB current will be 0 micro ampere means this is cutoff region occurred in this part, and then we can increase the IB value like 10 micro ampere, and then IB is equal to 20 micro ampere up to IB is equal to 60 micro ampere. The saturation region will be occurred like this, and then this overall part is called as active region. So, this is the basic common emitter output characteristics of transistor. So, these are the comparison between and important terms of active region, saturation region, and then cutoff region. So, directly we can go for common collector configuration. Define collector configuration. Collector, it can be directly connected to the ground, and then base collector part is act as a input characteristics, then collector and then emitter part is act as a output characteristics. So, now we can go for the logic diagram for common collector configuration. So, this part is emitter part, so IE current flow like this, and then this part is collector is directly connected to the ground, then base part is connected to the one ammeter, and then parallelly connected to the one voltmeter. This part is connected to ground, and then here a resistor RB, then power supply. So, base terminal in forward bias means for power supply the positive terminal is connected to the resistance, then negative terminals is connected to the ground. Here the positive means here also we can put positive, then here also we can put positive, the negative will be goes to ground, and then ammeter negative part connected to the base current. So, the current flow is like this. So, this is the forward bias, and then emitter is connected to the one ammeter, then voltmeter, and then another part is connected to the ground. So, this is the RE resistance. So, reverse bias means the emitter will be connected to the negative terminal of the power supply, then positive terminal will goes to ground. Here we can put negative means here also we can put negative, then positive will goes to ground. This voltage is named as VCC, and then this voltage is named as VBB. So, this voltage is VBC, and then this voltage is VEC. This current flow is called as IE, and then this is IC, and then this is IB. From common collector configuration, we can go for the input characteristics of common collector. Here we can take the VBC, base collector voltage is in x axis, and then y axis we can take IB like this, here up to 10, 20, 30 microammeter. So, the plot is like this in input characteristics. Here the VEC like 4 voltage, then here VEC is equal to 2 voltage, we need to put constant, and then we can go for the output characteristics. Again voltage is VEC, then IE is a input output current. Here again we can go for cutoff region and then saturation region, like this the graph will be occurred. Here the constant is IB value. So, this is saturation, this is cutoff, and then the full active is active region. So, this is the input and then output characteristics about common collector configuration. For common collector configuration, we did not get hybrid parameters, we did not calculate the hybrid parameters because it is a emitter follower. Then we can see about comparison of or definition of alpha, beta and then gamma. So, alpha is a common base amplification factor, beta is a common emitter amplification factor, then gamma is a common collector amplification factor. The alpha is defined as beta divided by 1 plus beta, then beta is equal to alpha divided by 1 minus alpha, then gamma is equal to 1 plus beta. This is the definition for alpha, beta and then gamma. Then we can go for directly for comparison about common collector, common base and then common emitter. So, the voltage gain, it is a hybrid parameter for transistor characteristics. The voltage gain for common base is very high, then common emitter is also high and then common collector less than unity. Then current gain for common base less than unity, for common collector high and then common emitter high, then common collector for high also. Then power gain, common base moderate, in common emitter very high and then common collector is moderate. Then phase inversion, here no, common emitter yes, then common collector is no, and then input impedance compared to other two configuration, base will be low, then common emitter is moderate and then common collector is high. Then output impedance, for common base very high and then common emitter moderate and then common collector low. So, the applications of common base, common emitter and then common collector configuration is, here we can use high frequency circuits and impedance matching circuit. So, this is the comparison between common base, common collector, common emitter configuration. So, thank you for watching transistor configuration in series 1, series 2 and then series 3. Thank you all.